Hello, everybody.
Hi, Andrea.
Hello.
So good morning, everybody. Welcome to the TST meeting. We haven't had one for last couple of weeks due to conferences and other events. So this morning we have Davide Sanvito to present us with a proposal for basically a modular route optimizer, which is external to ONOS and which uses AI and machine learning approaches to augmenting the path through the network. And so with that, I'm going to pass the presentation to Davide. Good morning and thank you, or good afternoon for you, and thank you for taking the time to do this. Looking forward to it.
Okay, thanks for the introduction. I'm here with Daniele, who's also going to work with me on the contribution to ONOS. So, can you see the presentation?
Yes.
Otherwise, you can find the link in the GoToMeeting chat, if you cannot see what. So, the main motivations of this work are the following. So, the intent framework, as you know, allows to specify high-level policies without worrying about the low-level details. Another interesting feature is that as soon as we have some changes in the environment, such as link failures, the intent frameworks will transparently recompile the intents. So our question is, can we reactively take into account the statistics of the flow in order to optimize a global network objective? For example, we might be interested in minimizing the maximum link utilization. Many of you have seen our demo in the ONOS build. The main idea was to define a new smart intent whose compiler was able to monitor the statistics of the flow and try to periodically reoptimize the paths according to the collected flow statistics. In this way, any application can benefit from this recompilation logic. The main problem is that the initial idea was to integrate an optimization tool inside the ONOS core, but this probably would kill the performance of the ONOS instance. So after a discussion with Carmelo and with Andrea, we changed our mind. So we changed the approach. The idea now is to split the flow monitoring and the enforcing of the path, split from the routing logic itself. So the routing logic has been moved to an off-platform application. In this way, the application developer are able to define their own plug-and-play routing logic. This routing logic can apply optimization tool, machine learning, or artificial intelligence according to the traffic statistics which have been exported by the ONOS module. Another interesting possibility is to reuse their existing traffic engineering tools and just use ONOS to enforce the routing inside the network. So this is the big picture. The application developers submit a set of intents to this new module. We call it monitor and reroute, to ask this module to monitor the statistics related to this flow. The new module installs the intent and at the same time propagates the flow statistics to the off-platform application. Once the off-platform application decides to modify the routings according to the statistics, it can enforce and send the new routing configuration back to the module, which will enforce the routing using the intent framework. This is a workflow example. So this is the traditional, the standard ONOS core. This is the new module. So the ONOS application submit intents to this module. The module submit the intent to the intent framework, and at the same time registers for flow statistics event related to the intent received by the ONOS application. As soon as the module receives flow statistics events, it propagates them to the optimization and rerouting logic, which is implemented as an off-platform application. This external module can then send a new routing configuration to the module, which will enforce by using the same intent framework. So these are the main features of the new module. The new module has to offer a service to the other ONOS applications in order to receive intents to be submitted and at the same time monitored. The module has also to create a mapping between the intent, yes, to monitor, and the flow rule, which actually implements the intent into the switch flow table. In this way, the module is able to filter the flow rule event just for the flow related to the intents which have been to be monitored. So at the same time, the module has also to offer a REST or gRPC API to make these flow statistics available to the platform application. Finally, this module offers another API to receive the new routing configuration from the external module and to enforce it in the network, in the switches. So the first point which has to be solved is how can we enforce a routing by means of the intent framework. We selected different possibilities. The first one is try to reuse the path intent or the link collection intent, which allow to specify an explicit path. The main problem here is that the path itself is part of the objective. So in case of failures, the compiler cannot transparently recover from failures because the path itself is the objective. So another possibility is to make the new module handle the failure in a way similar to the point-to-point compiler. So in this case, the module is in charge of computing a backup path and to configure the fast failover mechanism into the switches. This is not the best possibility because we are reusing the same code of the point-to-point intent compiler, and also this functionality might be useful to other application developers. So this is actually a module which can be reused. So maybe the best idea is to define a new intent with a suggested set of paths. So in this case, the path is not the objective, but it's an help for the compiler to decide how to compile the high-level intent. In this case, the compiler checks if the suggested paths are available in the network. If not, it can fall back to the classic shortest path approach. But since this approach is very similar to the operations performed by the point-to-point compiler, maybe we can directly modify the point-to-point intent to include the set of optional primary and or backup paths. So this is what we need to discuss. Okay, so these are the interactions between the ONOS module and the off-platform application. Of course, the off-platform application needs to retrieve statistics. We can have two approaches. The first one is based on REST interface. This is a pool-based approach. So the ONOS module would need to cache the flow statistics while waiting for the off-platform application. This might be problematic because in case of big number of flow to be monitored, we can have a high overhead in terms of synchronization between the ONOS instances. So maybe a better approach is to use gRPC because we can directly push flow rule event as soon as the module receives them from the core. The second interaction is to enforce new routing configuration. So in this case, it's the off-platform application, which is pushing information to the ONOS module. In this case, we can both REST and gRPC are viable approaches. So the idea is to define a common interface for this communication and offering both the two implementations, so the one using REST API and the one with gRPC. Okay, we tested this idea in the demo I presented at ONOS build. So we built this proof of concept on top of a SDNAP application. So the idea of the contribution is to offer this new module to be used by any application. But in the demo, we explicitly modified a specific application, which is SDNAP. So we used the SDNAP tutorial network, and we fed it with real traffic traces from the Davide network. We monitored the maximum link utilization over the 2 days, and we compared the standard SDNAP application, which just forwards traffic according to the standard intents, let's say. So each flow is forwarded just on the shortest path. We compared it with our extended SDNAP application, where during the first day, we forward traffic using the shortest path. But at the same time, we monitor the traffic statistics, and at the end of the first day, we fed this data to the optimization model, which is able to compute the routing to be applied on the traffic of the following day. So in this case, we defined 2 different periods. We have a training period, for example, a day. It can be also 12 hours. You can decide what to do. And during this training period, we collect the statistics. And at the end of this first period, we compute for the configuration to be applied for the following period. The idea is to exploit the quasi-periodicity of traffic on a daily basis, and to define an optimization model in order to compute a set of routing configuration to be applied for the following day. The work about the optimization model and the algorithm has been developed in collaboration with Huawei France. These are the results of our demo. So we are comparing the maximal link utilization over the 2 days. So the maximal link utilization is the worst case utilization of the link, so the ratio between the bandwidth and the capacity. And in blue, we can see the maximal link utilization with the legacy, let's say, SDNAP application, while in red, we are evaluating the performance of the extended SDNAP application. We can see that during the first day, of course, the performance are comparable because we are applying the shortest path in both cases. But during the second day, we are able to obtain a gain in terms of average MLU, thanks to the routing compute with an optimization model. This is a short video which I presented the demo. It's very short, so maybe I can show you if you want. Okay, so in the top we have ONOS instance and the Milan network. At the bottom there is the off-platform application. We start the Milan network. In order to replicate the traffic, we use the hyper-free instances between a pair of nodes. We replicate the traffic according to the data from Davide network, and we took traffic matrices from 2 following days. Once traffic is started, we monitor the maximal link utilization by periodically polling the switch port statistics. So here we can see the maximal link utilization during time, the first day and in the second day. In this case, we are using the legacy SDNAP application. So as I told you, we are applying shortest path in both days. Now we repeat the same experiment with the extended STD application. During the first day, we still use the shortest path forwarding, but at the same time, we are collecting statistics so that at the end of the first day, we can compute the set of routing optimized to be applied to during the second day. And as you can see, you can obtain a smaller average maximum link utilization during the second day. Of course, we can iterate the approach. So during the first day, we collect data, we optimize the routing, we apply it to the second day. But at the same time, during the second day, we can collect data, optimize, and apply it to the following day. We want to thank you, Andrea and Carmelo, for the interesting feedback. I also got much help from other ONF guys during the ONOS build, which helped me to solve some issues I got still open. And also Andrea made himself available to help us here in Milano for the code review process. So I want to thank you, Kim. Thanks, Andrea. This is the plan for the contribution we want to do. In the first release, we want to define the interface and implementation of this new monitor and readout module. So basically, we want to extend, to extract the logic we implemented in the extended SDNAP application to make it available for any user-defined application. So in this case, the module will be able to receive intents from other applications. It will submit them and start to monitor their flow statistics. At the same time, we are exposing a REST API to make the external module able to collect the flow statistics, and at the same time to make it able to configure new routings by specifying the explicit path. In this first version, we are enforcing a given routing by using existing intents, such as the path intent or link collection intent. Of course, the plan is also to contribute with an example of an external application which can implement some optimization by considering the flow statistics collected during the day. In the second release, we plan to add the support for gRPC communication between the module and the external application. So gRPC can be used to retrieve flow statistics, but also to configure the new routing. In the second release, we plan also to try to modify existing intents or add a new one in order to allow a seamless failure recovery. gRPC might also be used to propagate the topology changes in order to make the external module aware of eventual changes in the network state or in the network topology. Finally, we have a third release. Actually, this wasn't part of the official proposal, but it might be interesting to discuss it. So the idea is that user application can request not only to monitor a specific intent, but also to monitor a general treatment. For example, the external application might be interested in collecting the statistics of HTTP traffic or SSH or a specific traffic pattern. So we want to make the external application able to do this without asking for a specific intent monitoring. So in this case, if the user application requests to monitor HTTP traffic, the module will propagate to the application all the flow statistics corresponding to flow, including HTTP traffic, any of them. We have some open points we would like to discuss with you today. So the monitor and reroute module orchestrates the communication between the user application, the intent framework, and the external off-platform application. Our plan is to implement it as an application which offers a service. So we were wondering if this is the proper position in the architecture, or if we should implement it as a core service. The second point is which is the best way to enforce routing configuration. So our proposal is try to extend the point-to-point intent, if you remember, to add an optional set of user-defined paths. Finally, this is a more philosophical question. Since the intents are topology-independent abstraction, we were wondering if it's correct to put a topology-dependent information, such as a path, as a constraint in the intent itself. So, is it correct, or it is the wrong abstraction? Thanks for your attention.
Okay, so so this is it. I just want to make sure I don't jump in too early, right? Okay. Yeah. Okay. Sorry. I see that it is a live slide. I just wanted to make sure that I didn't jump in and interrupt the flow of your presentation, which was excellent, by the way. So yeah, this is actually quite interesting that you asked these open points in here, because I was writing down notes and I had some questions about how you plan to address some of these things, and you asking effectively the same questions that I had. So this is great. So at least from my viewpoint, if you were to look at the open points one by one, I think it's definitely the correct way to implement it as basically a service. Now, whether that service is implemented by an application or a core module, we can discuss at a later time. I would suggest for now we started with as an application, because we can always promote it to the core if it's appropriate.
Okay.
And as far as the last 2 points, which have to do really with the enforcement of the routing configuration and how to represent the constraints from the external application to the intent service, I think using a constraint is perfectly fine. As a matter of fact, that was one of my suggestions as you started to describe it earlier in the presentation. I think it's perfectly okay. We already allow constraints which are effectively either waypoints or obstacles for intent. Yeah. And so this is basically just an extreme case of waypoint constraint effectively.
Exactly. But the problem that there was that when using waypoint constraints, you are limiting the selection over the set of shortest path. But maybe your external logic may decide to select a non-shortest path according to some other metrics.
Oh yeah. To be clear, I was not suggesting that we use the waypoints and then let go back. I was simply you pointing it out as an example of a topology-specific piece of constraint in an intent. So I think you're at least from what I've surmised from what you were talking about, is you're suggesting that we have a constraint of a suggested path or suggested paths, and if that path is viable given the existing state of the topology, that should be the path that is selected by the intent compiler. And I think that approach is perfectly fine.
Okay.
Right? So this way you completely circumventing the choice, basically the use of the default path service by specifying your own path to be plotted through the network. And I think that's perfectly okay. You can still benefit from the intent framework clearly by doing all of the flow programming and other things like that.
Great.
So I think that approach would be perfectly okay. So for the point-to-point intent, or potentially some other derivatives of the point-to-point intent, if we were to add a soft constraint of suggested paths, the compiler should be able to be fairly easily modified to use those if the paths are available.
Perfect.
At least that's my, that would be kind of my suggested approach.
Hi, this is David Bainbridge. First, I agree with Thomas that this was an excellent presentation. Some really interesting work here, and I appreciate the presentation. On the first point, I had a question, really. I interpreted this kind of the first open issue as, should this be implemented, continue to be implemented as an external application outside of ONOS versus an ONOS in-process application versus ONOS core, part of ONOS core. Is that kind of where you were trying to go with that question?
My question was, what is the, if we have to implement it as an application, or, I mean,
when you said implemented it as an application in the first open issue, did you mean it as implemented as an application as it is today, external to ONOS, or did you mean implemented as an application internal to ONOS?
Internal, yeah.
Pardon?
I mean, the extension to ONOS is the module to orchestrate the communication between the external module.
Okay.
So the external is the application which decides the routing according to statistics, while this monitor and reroute makes this reroute monitoring.
Okay.
Yeah, that's what
Thanks for that clarification.
Yeah, that's what I understood. Is effectively the bulk of the heavy lifting in terms of the tracking the historical data and then deriving from the data basically the reroutes, right? The optimal routes. That heavy lifting would be done off platform, but we still need to have some presence, at least minimal presence on platform in order to facilitate conveying the data, the statistics, as well as the intent constraints downwards.
Because another possibility is to, I don't know which is the current support, but if the intent framework offers gRPC interfaces, another possibility is to, implement all the logic outside of ONOS, but maybe it's easier to have an in-platform application to orchestrate the communication, while as an off-platform application, we just keep the routing computation itself.
Yeah, I was actually wondering if that kind of on-platform application becomes a more generic mechanism to expose metrics, whether that's via Kafka or some other mechanism, such that you say, here are the things I'm interested in, and they could be flow-specific or protocol-specific. And that translates into events being sent over this kind of message bus, if you will, to any external application. So this kind of becomes a reusable module. And then, yeah, using something like gRPC or REST to program ONOS back for the intents with the path-specific constraints. That way it becomes more of a kind of a generic interface between external applications and ONOS, and might have some applicability beyond what you guys are doing.
Yeah, so I guess I was viewing this as simply a provision, the on-platform piece, as simply a provisional piece until the generic bits become available, right? Because in theory, there is really no reason one would need to pass the event through this module. You should simply be able to pass your intents directly to the intent framework, and either they have the constraint or they do not have those constraints.
You can see that the monitor route allows to pre-filter flow stats event in order to avoid to propagate all of them to the external world.
Exactly.
It's like pre-filtering.
Yeah, I wasn't assuming that we're going to propagate all events. I assumed there'd still be kind of a filter interface into this module that says, hey, here are the things I'm interested in. So you still wouldn't be propagating everything, but it would become a more generic event or message request, if you will.
Yeah, and right, and this is kind of in line with what we discussed with the process disaggregation approach, anyway, right?
Yep.
So
yes,
and the idea is that once the gRPC, sort of the core and application gRPCs become available, we can start exercising them in that context, and hopefully that will preempt the need to create custom modules such as the monitor and reroute in the future. But I think for now, in order not to get tied to existing work in progress, I think having a small module that helps facilitate this specific functionality is perfectly okay.
Okay. Another possibility is to have, to justify the need of this module, is to have multiple external applications. So in this case, we can have multiple inside application which registers to the monitor and the route. And so this module not only pre-filters the events, but also ensures that each external application just receives flows concerning its own flows.
I see.
This is another possible motivation to have this. So maybe we can filter the flows according to the application ID, have something similar to the external application, so limiting the exchange of data between different applications.
Yeah. And a benefit also having it as a sort of internal, sort of offering the internal interfaces too, is that it allows some on-platform applications to kind of decouples the external and internal apart from each other. And so you could actually have other applications that are all on-platform asking for similar services. Or asking for the same service, really, is what I meant to say.
So this is Brian O'Connor from ONF. I think what I would suggest you guys try to do is kind of in line with what David's ask is, and that is rather than create like a monolithic monitor and reroute shim application in the long term. I mean, obviously, if it's going to happen in the short term to just you guys make progress, that's fine. But in the long term, it would be ideal to try to think about what services you're offering and how they differ from services that we already plan to or already do offer. So for example, like topology, when that gRPC model becomes available, it would be ideal, if that could be leveraged, and if you need to provide feedback or more information there, that would be fine. For things like the intent service, it would be great if the existing gRPC models, the core services, could be used. I think the service that needs to kind of be created is a high-level intent stats service, where we actually provide some correlation between the flows that are on device and the flow stats that come back and the intents that are there. Ideally, a general purpose intent stats service would provide some filtering mechanism, either by intent ID or app ID or both. And if we can appropriately correlate the flow rules and their associated flow stats to a given intent, then that second degree of kind of direct flow rule filtering might already be handled. So I think core services or sort of on platform near core services is ultimately going to be the way to go. But I would think about sort of dividing those services along functional lines rather than just combining all the services you need into one application.
Excuse me, can you repeat the final part?
Well, so I think, let me paraphrase if I understood correctly, Brian. I also need to do that for my own benefit. So in the process, in order to enable the external module to be able to do its work, it has to be aware of the topology. So correct, right?
Yep.
So it needs to learn about topology and be able to build the graph externally. So all of the information, including all of the events, have to be conveyed externally to the application. I presume here you're assuming to do that via the monitor and reroute module interfaces. So that's topology. Second, it needs to know information about the traffic on those links, whether it's flow stats, port stats, or what. It needs to know that type of information. So topology, link loading or flow stats. It also needs to know about the intents. Is that correct?
Sure.
So that it can compute paths for specific intents, right?
Yes, you think the endpoints.
Right. And I think but there may potentially be other pieces of information from the ONOS core that it needs to know. And I think from what I heard Brian say, he was suggesting is rather than coupling everything into a single monolithic interface, which conveys all of these different classes of information to the external application, you instead structure it more along these facets. And consider potentially using the existing planned gRPC interfaces to, instead of creating your new ones, to
probably these interfaces are already available. It's better if, I mean, it makes no sense just rerouting them based on the monitor reroute module.
Is that what you were saying, Brian?
Yeah, that's precisely it. I mean, the high level point is, yeah, for now, if you guys need to build whatever gRPC services in whatever format you want, that's fine. If and when you're ready to kind of split things up, you know, if we already have services, or you want to help contribute to finishing services that we have, that would expose things like topology or the intent service, that would be great. And then where there are gaps, service gaps, think along functional boundaries. So like stats correlation service or something like that. Yeah, basically you got it.
No, that's a good suggestion.
So another question that I had is, it's an interesting approach that you guys have, because one of the things that is still enabled here is it enables off-platform applications to more or less only be proactive. And by that I mean that ONOS's intent framework, for better or for worse, is still going to reactively respond to things like network failures. And so your approach basically would enable you to, through something like constraints, suggested and/or backup paths, provide provisioning recommendations to ONOS, and it could do so kind of in an ad hoc or periodic manner. But one of the things I'm wondering is that if you don't provide, if you sufficiently constrain an intent, like either by not providing enough backup paths or providing backup paths that have a shared failure link, a shared fate on a single link, it's possible that we could lose connectivity even when alternate paths do exist. And I'm just wondering whether these constraints or suggested paths would be like firm constraints, whether they are required to be enforced, or whether these constraints are just preferences, or how we want to express that.
Suggestions exactly for the same reason you are just pointing out, because this is the main problem. Yes, because if we put hard constraints, it's like we are asking as objective to explicitly pass through a set of links. But of course, if one link of our request fails, we cannot meet the objective. So probably it's best to consider paths as soft constraints.
Yeah, that's what I'm assuming.
So if the suggested path is available, we use them. Otherwise, we have this fallback mechanism. So we just select another path among the one available.
Yeah, I think that makes perfect sense. This notion of kind of like a soft constraint is not something that we've implemented before. So
Well, it's an issue of semantics, though, right? I mean, it'll be a constraint.
The constraints are objects, right? They don't carry any semantics. The semantics is in how you decide to implement your behavior based on those constraints.
Exactly.
And so we need to make the compilers aware of those semantics. And I would suggest using something like suggested because it implies kind of a softer constraint than alternate or
completely
paths.
agree. Yep, completely agree. One thing, this discussion also brought out kind of another possibility. I'm not suggesting that this is something that you would, you would deviate from your current path to pursue, but an interesting possibility might be, given the fact that effectively from the point of the external module which computes the path, it operates on two endpoints, correct? And then it uses the information that it learned about the state of the network to plot the alternate path through the network, the suggested path through the network using the traffic data. It would be interesting to see if he could come up with, basically, if he could hook this external logic for computing the path into the system path service itself, meaning that other applications, not just the intents, but let's say even reactive forwarding or any other application which is using the path service, could simply say, I would like you to compute a path between two endpoints using the ordinary path service that ONOS provides, and then be given an answer which is obtained by consulting the external engine.
Yeah, that's interesting.
You know what I mean? So this way the information becomes available to things other than intents.
So you make the external, the path computation itself. External,
exactly. But it would be available basically to everybody else internally as well.
So it's like an interface between the OConnor, a core piece and the external.
Effectively, yes. And then, of course, whether or not the path computation itself is done, always outsourced externally, or whether the external module simply compiles some data for path computation, some link ways, and then ships it off to ONOS for computations of the paths themselves to be done on ONOS platform. Those are the various possibilities. But if you were to pursue the sort of the faceted approach that Brian suggested, perhaps this class of information through which basically the path itself is conveyed to the system is separate enough, it could enable this approach. Clearly, initially you would do it as you have it where it's tied to the intents themselves. But in future, it could potentially be extended to just the path service itself.
Because one of the main motivations we used the external part was that we were interested in optimizing jointly the intents, the paths. So we wanted to, the effect we'd like to obtain was that each intent was compiled, take into account the statistics of all the set of all the other intents.
I see.
To minimize a global objective, but what we found out is that each intent was independently compiled from the others. So,
well, I mean, the thing is, let's say, okay, now if we set aside what I was talking about and then just focus back on this specific issue of compiling intents. So yes, they're compiled independently, and I assume. Okay, so once the intents are, assume that the network remains undisturbed, which means the topology remains the same. And let's say, as you've learned, you observe the traffic one day, and then you decide, okay, now it's the time to start acting on the traffic, to start to relay it out, right? And this could be prompted just by just some event, which does not have to be a topology change event. That's when you may want to decide basically to resubmit all of the intents now with alternate suggested paths. Of course, you could do this as often as you wanted to in theory. And you could do it in bulk potentially. So whether you could do it individually, where you do that for each intent, where effectively the off-platform path compilation is done on intent by intent separately, or it could be done in bulk, where you take a look at inventory all of the intents, try to pack the traffic onto the network using the suggested paths, which are computed sort of jointly as part of one big computation. And then you could update the intents themselves on the system. So we have various possibilities, right? You could certainly do such group-based packing, or you could do individual computation. I presume initially you're doing individual computation, correct?
Yes. Mm-hmm.
And so in the context of the individual computation, such services could be made available through the path service itself. Clearly, in case of the bulk packing, that would not be the case.
Yeah, that's interesting.
But clearly, the second problem where you're doing things in bulk, I mean, that's going to have all the complexities of a bin packing algorithm.
In this case, it's like we are asking to the external module to recompute reactively the intents.
Yeah, no, this is really interesting. So since you've demonstrated, so if you unless there's some other questions, I would like to turn towards the logistics sides of things here. You demonstrated this at ONOS Build, and you have a video presentation of it. So how close do you think this is to submitting it as kind of as an application, both to the ONOS code base, and second part is how should we go about distributing or making available the external piece? Because so far we've been dealing mostly with on-platform applications for which the problem is fairly straightforward. You know, you check the code under ONOS code base. It gets, if it's properly linked into the build system, it gets compiled, staged, and can be activated through the application subsystem, and everything is fine. But now we have to worry about a third piece, right? We don't have any way currently to manage off-platform applications just yet. How they get built, whether they're platform specific, whether, you know, how do we manage their ignition, and sort of tools to sort of manage now this external entity. Did you have any sort of ideas on how to manage that? Would it be just documentation and some sort of scripts or tools?
So for the first question, we plan to at least the first release to make it available by the end of the year, maybe also the end of November. For the because it's like we need to move the logic away from the SDNAP and make it available as an independent application. Well, for the second question, I mean, your question is how to make it available. The external module is an open source contribution, right? Are we planning to? I mean, is it okay if we create a dedicated repository where we put some example external modules, such as maybe some algorithm, some model which doesn't need a commercial solver, but it relies on some greedy algorithm so that it can be used by anybody with no problem in licenses. And you can also put a small README with some example how to run it and test it.
Right. So, so hopefully such external modules could be built by anybody. Again, as you said, without any license restrictions, or could be built by anybody, and then there would be a sort of runtime collateral that would allow anybody to be able to start it and test it. And by collateral, I mean things like scripts, external tools, and documentation, so that they can easily set up this environment for comprising of both the ONOS and the external module. So because in this case you're sort of paving a new path. Clearly, in the long run, as we start to disaggregate ONOS, both in terms of repositories and in terms of the process itself, we will have to solve these issues. And hopefully the apps will just benefit from the common approach that's set up for them. But for now, we don't have one, and so you're going to be faced with supporting one yourself. So I think, starting with speaking of the collateral, I mean, initially it could potentially start as just documentation. This is how you build this external piece. This is how you start it. Just some commands, instructions for how to start it up and how to link it up with the ONOS itself, and that might suffice initially. And then once it's in place, we can keep embellishing it. And by we, I mean the community as a whole, which would include your. Well, this is really interesting. Is there any other questions from the attendees? If not, then unless you also have something to add from Italy, I would like to thank you for putting this together. This is really nicely done presentation and really interesting concept, and we're looking forward to seeing those contributions coming.
Thanks also for all of you for the interesting discussion. And as I told you, I will be also in contact with Andrea Campanella here in Milano. So
perfect.
He can help us in getting started with the official contribution process. So I'm sure you can.
Yep, and don't hesitate to reach out if you need support for, let's say, if you need a home for this code. We can set up a repository for it to be housed in, and we can set up a carve of a wiki space.
Okay, great.
All right.
Yep.
Thank you very much. You guys have a nice evening, and for everybody on the West Coast, have a nice day.
Thanks a lot, everybody, and very good presentation, Davide. I'm gonna be happy to work with you guys. Bye-bye.
Bye-bye.